Hello everyone. This is the first video of this series on how to build chess in Java from scratch. And as you see, I've downloaded the latest version of IntelliJ IDEA currently. So we can create a new project now. Mm, and, and we can name this chess in Java. Yeah. Mm, oh, yeah. Mm, okay. Now we can begin by creating a new package, which is gonna be oh, a package. Hey, yeah, a new package which is com chess board. Yeah, and in this I told that this is a video of the piece class, but before that I want to flush out the tile is a relatively small class for now. If you want, we can come back and refactor this later. And I want to introduce certain member fields here. The first one is going to be a private final position. Yeah. And next, a private piece on tile. And create class piece in the destination package com chess piece. And position is gonna be a class which I'll create in com chess. Yeah. Okay. Yeah. And this is complaining because we haven't initialized this. And constructor parameters. Yes. Okay. Make this final as well. And we can make this constructor private and introduce a static factory. Public static tile get instance, and this is just return a new tile with a position. A position. Yeah, that's it. So here we can give position here, and we just need to introduce some getters and setters. So a public piece get piece on tile, and a public position get position, and a public void set piece on tile. This is final, and the semicolon here. And yeah, we're done with the tile class for now. If you want, we can come back later. So another important class we're going to introduce in this Java chess project is the position. Position is so important as each tile is gonna, position is the key for each tile's position on the chessboard. It has an x coordinate and y coordinate, which simply represents the row number and the column number. So yeah, we can start by introducing these x coordinates, and another member field which is the y coordinate. Private final, this as well. And we can ask the IDE to add constructor parameters. Yes. And for this as well. And okay, here and here. And some important things we need to do in this position class is that we need to override hash code and equals. And obviously the reason is because we want to compare two positions, though they can be really different objects with different IDs, but we're going to override equals and make object positions with the same x coordinate and y coordinate equal. So I'm going to override hash code first. Public int hash code, and this is just going to return 31 times x coordinate plus y coordinate. And when I override equals, this will be relatively simple. Public boolean equals. And we have to pass in an object here. Object obj. And this is maybe final. And we can return this dot hash code double equal to other dot obj dot hash code. And this should be fine for now. And we can, I think these both are flushed out, and we can come to the piece class, the class we've assigned for today. And in this piece class, first of all, I'm going to introduce certain member fields, which are a private piece on tile, private, this itself is a piece. Okay, so private tile, current tile, yes, and a private position. Position is going to be a frequently used class in this project, hopefully. Private position, and we can initialize it in the constructor. So first of all, we need we can make this final. We need a current tile here, and we're gonna assign it to our current tile, and this dot piece position. I want to name it piece position. Sorry, piece position. Yeah, this dot piece position equals current tile dot get position. Good. And a few more things here. Piece type. This I have to introduce this. Create enum piece type in ComChess piece, and this is just gonna contain now pawn and knight, bishop, rook, king, queen. Pawn, knight, bishop, rook, queen. That's fine. That's done good. And I want to introduce a constructor for these, which is just gonna be short piece type, and this is just gonna contain a final int points. The points each piece type holds. So if you know chess well, you must be knowing that a pawn has 1 point, and a knight has 3, a bishop as well has 3, rook 5, king has infinite, and queen has 9. So this is just gonna give this dot points equals points, and we haven't introduced that member field yet. Create field points, private final int points. and we're gonna introduce getters. Yes, and we need to pass in the points for each. So pawn is gonna contain 1, and knight is gonna contain 3, bishop 3 as well, rook is 5, king is double dot positive infinity, and queen is actually king is something different. Okay, we can make it integer dot max value, and queen is gonna contain 9. Yeah, I think it's well done. Okay, we can come back to piece, and each piece has a piece type, private piece type, and final here. This is just gonna set up piece type. This dot piece type equals piece type. Okay, and next I want to introduce certain crucial member fields, which are a list of positions, not this, position, candidate move coordinates. Bear with me for a while, I'll explain it to you. And a list of tiles, private list of tiles, which is gonna be legal destination coordinates. And this candidate move coordinates is gonna be equal to get candidate move coordinates, yeah. And we cannot define, okay, wait, first of all I have to explain you what candidate move coordinates and legal destination coordinates are, if you haven't understood. So we'll take up the chessboard. So if you know chess well, you must be knowing, of course, that each piece has its own rules for moving. A pawn, if it's its first move, it can move 2 steps front, else just a step in front. If there's an opponent here or here, that will be added to its legal moves. A knight can move 2 steps in the front and 1 step towards the side. So as you know, each piece moves in a different way, and the set of rules defined in the chess book is the candidate move coordinates. And there's another member field I've introduced, which are legal destination coordinates. I'd like to remind you one thing, that these candidate move coordinates, that is the rules defined in the chess book for how a piece should move, never changes. Anywhere it might be on the board. But the legal destination coordinates, which simply represent where the piece lands on, changes. A knight here can move here, but it can't move here, of course. But if the knight was here, it could easily move there. So each time a piece is moved, the legal destination coordinates must be calculated. Any piece is moved on the board. Like even if this pawn were to move here, this knight would lose this legal destination coordinate. So anytime a piece is moved, we have to calculate each piece's legal destination coordinates, while the candidate move coordinates remain the same. And one more thing I want to explain you is a limit. So a knight, how many times can it move 2 and 1? How many times can it repeat its candidate move coordinate? So it can go here, here, and that's it. It can't go here, it can't repeat its 2, 1. But a bishop can. Like, ignore this pawn for now. A bishop can move 1, 1. So 1 and 1. But it doesn't need to stop here. It can go infinitely until it is valid. and it is not an illegal move. So knight has limit 1, bishop has limit infinite, and so does a rook and a queen. King has limit 1, and pawn as well has a limit of 1. So hope you have understood. And so this can just be initialized here, and but one thing is that a generic class piece can't get candidate move coordinates. Like, it can't define its candidate move coordinates, as it should be left to its subclasses. Each subclass of piece should define this, so we can make piece abstract. And yeah, yes, and we can move this down. Alright, we got this down, and we need to create a method for calculating the legal destination coordinates. So private list. This list of candidate move coordinates can be protected, but this should be private, because a generic class piece can't define its candidate move coordinates, but I hope it can define its legal destination coordinates using this list of candidate move coordinates. And the key difference between these both is that this is a tile list and this is a position list. And list of tiles, calculate legal destination coordinates. Okay, and we can just give here list of tiles and list of tiles, legal moves. Calculate legal moves. This would be easier. Legal moves equals a new array list. And wait a minute, I need to explain you another thing, so I'm going back to the be patient. Okay. Alright, so here the key logic, the basic logic behind calculating a legal destination coordinate is taking the current tiles row number and the current tiles x coordinate and y coordinate and summing it up or adding it up with the candidate move coordinates x coordinate and y coordinate. For example, this knight would be on 0 in x coordinate and 6 in y coordinate. It starts from 0. Okay, here in this program. So in 0 and 6, we must add 0 and 6 with its legal candidate move coordinate, which is 2 and 1. So 0 plus 2 is 2, and 6 minus 1, or maybe you can go here, 6 plus 1 is 7. So this has brought us to this position, and this is a legal destination coordinate, and so is 2 and minus 1. Alright, this is 0 to 63 here, so I got the wrong order. And so can it go here. You're adding the x coordinate and y coordinate of this position with the position with a candidate move coordinates, x coordinate and y coordinate. If you haven't understood here, hold on, and when I program this, you'll understand. So here we can, and one more thing is that we should loop through each candidate move coordinates. Like when I explained, I told simply that a knight can move 2 and 1, but that's not the only candidate move coordinate of it. It can also go 2, minus 1, all different combinations of minus 2, minus 1, 2 and 1. And it has 8 candidate move coordinates. So we must loop through each of them. Position I, colon candidate move coordinates. And here I'm going to introduce a few variables for code readability, which are candidate x coordinate. I hope you understand what this is. So candidate x coordinate is the x coordinate of a candidate move coordinate, and a final int current x coordinate. This is the current piece position's x coordinate is equal to piece position dot get x coordinate. Oh, haven't I introduced that? Wait, I'll go to the position class. Position. Okay, I haven't introduced getter methods for these. So public get y coordinate and public in get x coordinate. Yeah, and here we can call these methods. And a final int candidate x coordinate. We can rename this to position. It's clearer. Equals position dot get x coordinate. Oh, this must be y coordinate. Sorry, y coordinate, and here as well. This is position dot get x coordinate, and a final int current x coordinate is equal to piece position dot get. Okay, this is current y coordinate. Sorry. Yes. And next, the next step we have to do is we have to get the destination tile. And as I explained you then on the chessboard, the destination tile should be calculated by getting the tile of the position which corresponds to the candidate x coordinate plus current x coordinate and candidate y coordinate plus current y coordinate. So yeah, we can do this. Board dot get tile. This method is not introduced yet. Even this class isn't. Candidate x coordinate plus current x coordinate and candidate y coordinate plus current y coordinate. Yes. And we need to pass in the board here. Final board, and here as well a private final board, and we can initialize this board equals board. Okay, we don't have this method called get tile. Oh, we don't have the board class as well. So create class board. Destination package is com chessboard. And now we need to introduce this method get tile in board, tile get tile int x coordinate and int y coordinate. Yeah, this should be fine. This returns this dot get tile a new position x coordinate comma y coordinate. Yeah, and this method as well is in the import class comchess, and so we need to introduce this method. This can be final here and here as well, and here, and this just returns board map dot get position. Alright, create constant field map will be position Come on. Here position tile board map equals this isn't static, and we can for now, to avoid the compiler error, initialize it in the constructor. Board map equals null. We can come back and change this later. Java util map, yes. Okay, this is not that good in the best shape, but for now, to avoid the compiler errors, we're doing that. So we got the destination tile, and I want to introduce a null check here, because you must realize that a candidate move coordinate could also be negative, as like a piece is going backwards. So sometimes it may result in out of board coordinates, and when I get them from the board, it will result in null. So I'm giving a null check. If destination tile double equal to null, then continue, as I don't want a null pointer exception. And next, I'm going to loop through loop until a tile is valid and the limit is not crossed. I mentioned about the limit earlier. While bounds checker dot is valid destination tile dot get position and raise less than limit. Okay, and in j equals 0. Yes, and here create class bounds checker in com chess. And this is not going to contain much, but just a method which checks the bounds and make sure it's not out of bounds. So public static boolean is valid, and this just gets the position, a final position, and returns position dot get x coordinate less than 8, and position dot get x coordinate greater than equal to 0, and position dot get y coordinate less than 8, and position dot get y coordinate greater than equal to 0, making sure it's a valid chessboard. Okay, so now the compiler error should go away. And limit, I mentioned about the limit earlier, so we can pass that as a constructor parameter, limit, and we need here as well private final int limit. Yes, and we can initialize it in the constructor. So this dot limit equals limit. Why is it complaining? Oh, final int limit. We need to loop through this, but I think that will be our next video. So bye, thanks.